Chapter 16, Solving for pH of an Acid in Solution by Jackson Goldman. The question we are given is, what is the pH of a solution in which 224 milliliters of HCl measured at 27.2 degrees Celsius and 1.02 atms is dissolved in 1.5 liters of aqueous solution? So for step 1, we're going to find the moles of HCl using PV equals nRT, which we learned in chapter 5. We are given P of 1.02 atms, V of 224 milliliters, R is a constant of 0.08206 liters per atmosphere over moles Kelvin, and T of 27.2 degrees Celsius. We are using this R instead of the 8.314 R because we are not concerned with energy. Volume must be converted to liters by dividing by 1,000 milliliters in order for units to cancel in the PV equals nRT equation. In the same manner, temperature must be converted to Kelvin by adding 273 in order for units to cancel in the equation. From here, we plug into the PV equals nRT equation with the variables that were previously listed, and rearranging the equation to solve for N, which is the moles of HCl, you get N equals 1.02 atms times 0.224 liters over 0.08206 liters atmosphere over moles Kelvin times 300.2 Kelvin. Solving this, we get 0.00927, which when converted to scientific notation yields 9.27 times 10 to the negative third moles of HCl. Notice we have three sig figs as we started with 3 at the start of the problem. For step 2, we are going to calculate the concentration of HCl. We know the molarity equals the moles of the solute over the liters of solution. In step 1 of the problem, we calculated the moles of our solute HCl. So we have to plug that into the moles of solute in the molarity equation. The liters of solution is given to us at the start of the problem as 1.5 liters, so we can plug that in. Solving for this equation, we get a concentration of HCl of 0.0062 molarity, or 6.2 times 10 to the negative third molarity when converted to scientific notation. Notice we have 2 sig figs because we were given 2 at the start of the problem in 1.5 liters. Finally, we are going to calculate the pH of the solution. HCl is a strong acid, so it will completely dissociate in water. Thus, we can set up an equation, HCl plus H2O into H3O plus Cl minus. We know our concentration of HCl, we calculated in step 2, to be 6.2 times 10 to the negative third molarity. Water is a liquid, so we don't have to include it. And since HCl is a strong acid and completely dissociates, the concentration of both H3O plus and Cl minus will be equal to the concentration of HCl. From here, we can plug into the pH equation, where pH equals the negative log of the concentration of H3O+. Solving for this equation, we get a pH of 2.2.